Hello, protocols, packets, and programs. Today we leave 8 bits behind as we max out some powers of 2 to bring you an episode unsigned at number 255. In binary, that's 8 ones, and hexadecimal, that's 2 Fs, which is 2 more Fs than we have to give to cliches like humans are the weakest link, crypto that isn't cryptography, or 32-page hardening guides. I hope you've enjoyed every bit of my intros. They come from an 8-bit heart wanting to see our 64-bit present avoid the 2-bit security that has plagued AppSec for more than 20 years. So, help us take a bite out of insecure apps and see what the power of 2 hosts can do with interviews and news about the flaws we find in software. Which means, this week we chat with Karl Triebes about business logic and why those 2 words contain a multitude of challenging security issues. In the news segment, Azure and the 8XSS, CNCF and the 2 audits, CISA and the 1 roadmap, GitHub and the many race conditions, and more. Check for overflow and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Developers have a need for speed to meet market demands, and application security needs to ensure that data and privacy constraints are met. Unfortunately, that can slow down delivery. So, is it even possible to deliver secure software quickly? Enter Secure Coding, brought to you by GuidePoint Security's Application Security Services. Secure coding is more than a process, it's a cultural shift, one that will make it possible for both developers and AppSec to build in security while applications are being developed. Visit our AppSec Resource Hub to learn more at securityweekly.com/guidepoint.
This is episode 255, recorded September 18th, 2023. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Mr. Shima, you just gave me an idea. I wonder, with these 32-page hardening guides, if they grow a little bit longer, does that mean they reset down to 0 pages, so something might have easier hardening to do?
I like your thinking there. We just need to add 1 more, and keep it signed. So, let's play with those overflows. What else can we play with? We can play with a trip to Infosec World 2023. It's just weeks away. Have you registered to join over 2,500 cybersecurity experts on September 25th through 27th in Lake Buena Vista, Florida? Infosec World is your gateway to a world of knowledge and growth. Don't miss the chance to enhance your career, connect with industry leaders, and make an impact on the rapidly evolving landscape. Save 20% off your registration with code ISW23-SECWeek20. Register today at securityweekly.com/InfosecWorld2023. This segment is sponsored by Imperva. For over 3 decades, Karl Triebes has helped conceive and build products, services, and businesses for networking, application software, storage, and cloud. At Imperva, he leads product management for the Application Security Business Unit, driving product innovation for customers. Prior, he was Executive Vice President of Product Development and CTO at F5. He also has held senior leadership positions with Amazon Web Services, Foundry Networks, and Alcatel. Hello, Karl. Thank you for joining us again.
Great. Thanks, Mike. Glad to be here today.
Glad to have you. The 2 of us just talked back, it seems, I don't know, was it long ago or not too long ago at RSA?
Yeah, it seems like decades ago almost, just lots happened since then and now, to be honest.
It's been a busy year.
It has indeed.
And you have been busy still on the topic of business logic. And I like this topic because it's one of those areas that, as I mentioned in the intro, 2 words, but a multitude of challenges. And it's one of those things that doesn't really get expanded a lot on. It's just sort of, that's business logic problem. So let's start off with defining it a little bit or giving us some examples about what we mean when we say business logic.
Yeah, it's interesting. Business logic attacks been around for a while, but they're growing in scope and size, especially now due to the popularity of APIs and how endpoints are being exposed. And so, typically, business logic attacks, the way you would define it is, it's basically that type of attack targets a way the application's processes and rules are designed and executed. So basically, these attacks exploit vulnerabilities in the application logic. And what they want to do is gain either unauthorized access, they want to manipulate data, or perform actions that the application was not intended to allow. And this way, attackers can get data. They can affect what the application does. But generally, it's now it's for these monetary gains. And in fact, if you look at last year, a stat that we published was that 27% of API attacks were focused directly on business logic. And if you look at kind of the math around that, on a global basis, they say that effectively about $75 billion of loss can be attributed to API insecurities. So it's a big business, and attackers are making a lot of money off of that.
Indeed. And I think that aspect that there's money lost, I think speaks to the idea that business logic is going after workflows that can be monetized, workflows that are benefiting the attacker in some way, which is much different from SQL injection cross-site scripting. Now, I can think of scenarios where those are helpful for attackers, obviously, but I kind of shrug at cross-site scripting. You pop up a window, but it's not the same as getting tickets to the latest Taylor Swift concert, to then sell them on the secondary market. As you said, getting privilege escalation attacks, these types of things, right?
Right, exactly. Yeah, in fact, what you're talking about there, like, it's cross-site scripting or those types of attacks, those tend to not be that stateful, that they tend to be more, you can typically take care of those with more simplistic rules. That don't require a lot of time to kind of build up an understanding of what that attacker is trying to gain access to. Whereas the business logic attacks, since they are specific to your application, that is how you've written the application, how you traverse that application, what's available to you, how you're authenticated within that app, means that those vulnerabilities tend to be very specific to that. And so attackers typically will sit there and try to map that out and detect and discover those vulnerabilities. And so that tends to be a very stateful problem to go solve, and it's more complex and hard to manage. But nonetheless, that's where they hit pay dirt, like you're saying, is that there's a lot of money sitting behind that.
And that bringing that concept of stateful into it also points out that this isn't the type of, business logic isn't typically the type of thing that you can grep for. It doesn't matter how fancy your grep is or how simple your grep is to find those missing, this should have been a prepared statement, this was a cross-site scripting. There's state that doesn't, that is obviously the code represents, and the attackers are identifying this. So either from the attacker's perspective or maybe from the developer's perspective, how do you go about reasoning through that state of the application to figure out this workflow is going to be abused in some way, misordered or somehow?
Yeah, that's one of the hardest things for a developer. I come from a development background. And as a developer, you tend to be very focused on just making the application work. Ensuring that it's doing what it was designed to do. But the problem is, again, applications are big and very stateful, and there can be many kind of degenerate situations where you can find yourself in spots in the code where you can gain access to things that you shouldn't, right? You can branch from certain areas that you shouldn't be able to, or maybe you didn't authenticate a specific object or things like that. And so, there's a lot of things you can do as a developer to help, prevent that. But to be honest, when you got, let's say, 100 people contributing to a big, different pieces of code, and this all comes together, there's going to be gaps, that happen in there, right? And so it doesn't matter if you're good at looking at like access controls and doing things like that, which is good hygiene, and you should do that. But across this entire code space, you could be opening up vulnerabilities and things like that, right? And so you have to be very vigilant in your overall design practices, right? You have to ensure that your developers understand what secure coding practices mean, right? To prevent common coding areas, input, validate like inputs and outputs. One of the big exploits that lead to this is this concept of least privilege access. In fact, the analogy is in the container world. We're using containerized, let's say, open source applications. I can't remember who provided this report. Maybe it was Postman, but they said that they did a survey of a bunch of different environments, and they saw that 60% of these open source apps and containers were set at the wrong privilege level. And so that, of course, creates problems. And these are just some examples of this, but so it's very challenging for developers in order to get a handle on this. And of course, there's been some well-known exploits, very visible exploits that have cost companies a lot of money that have resulted from that.
And you mentioned input validation too, because that's one of those things that's, I'll admit, another one of my pet peeves is this really an input validation issue or not? It's like talking about cross-site scripting again. I'll try not to harp on that too much. But even here with input validation and business logic, a lot of these workflows, a lot of this behavior is conceptually what the application allowed, accepted, what you were supposed to do, just perhaps not in this particular order.
Right.
Meaning you don't have these obvious payloads with weird characters in them. This was a username. It's a valid username, right? And I think that's a really interesting aspect of trying to reason through, are we vulnerable or not? Just finding that proactively.
Yeah, probably a good example of this is on the API security world. It's in the OWAS top 10 for API security, about half of the top 10 relate to this business logic issue. And the number one is what they call broken object level authorization. And I can give you an example of this that hopefully will kind of an analogy, if you will, of what the issue is. And I like to use this analogy of you're going out to a nice restaurant. They have a valet that to park your car, and so you get out of your car, you hand the valet your keys, and he gives you a tag, and let's say the tag says 150. Now, as you're going into the restaurant, you notice this nice Porsche that pulls up behind you. Same valet gives the driver there a tag for 158. And so you go into the restaurant, maybe have a couple drinks and decide, maybe this isn't my scene, and I'd really like an upgrade on the car. So you come back and you doctor up your ticket to say basically that 0 to look like an 8, and you hand it back to the valet, and the valet then brings around that Porsche and off you go. And so the way to think about it is the parking garage was effectively the vulnerable API endpoint. The valet was the vulnerable code that didn't implement an authorization check. They didn't seek to validate you're the actual user. Perhaps if they had taken your driver's license or something like that, then they would have that additional check to validate that. And then the car was the exposed object. And so that's a very simplistic example of a business logic exploit where that object was not authorized, was not checking the valid authorizations to validate who that end user was. And again, that's the most common exploit in the API, the OWAS API sec top 10.
It is. And I also appreciate that you're talking to podcast hosts, and therefore we're obviously not the ones driving a Porsche in the first place.
Yeah, there you go.
John and I have talked about the OWAS top 10 list in general a couple episodes back. We'll come back to that in the new segment too. And the OWAS API security top 10 did just get refreshed for 2023 within the past week. One of the things that's interesting too, as you pointed out, the first one on the list is broken object level authorization. But then there's another authorization. There's another one that is unrestricted access, which to me sounds like authorization issues. That's kind of, there's too much of a comment in there rather than a question. But if I'm trying to pull a question out of that, it's like, how do we improve authorization on these APIs? Or is maybe this is too much of an emphasis and there's other issues, they're just being repeated, 4 or 5 times in this list?
Yeah, no, I think you're spot on. Is that the common thread is really, is this person or is this system during this session validating who this person is, and should they have access to whatever they're trying to get at? I mean, that's really what it comes down to. In fact, in most attacks, it comes down to an invalid user trying to access something they shouldn't. Whether you've done basically hijacked an account, or whether you're trying to violate, like with this broken object level authorization, or there's a whole bunch of these in there. But the more you can validate the user at each step of the transaction. And when I say transaction, I don't mean just where they're accessing the object themselves. It's like, there's typically like a logical flow through an application. You go from one step to the other, and this, kind of builds this progression, right? And you can see this a lot of times in like a regular web application where you put an object into your shopping cart, and you go through the whole thing with entering your credit card information, all these things, and then finally you check out and shipping author. There's a whole sequence of events that has to happen in order. Now, you don't want to have somebody like jump over specific specific, events, because that could leave out basically validation steps. And that's typically where you start running into these types of issues. So it's having validation checks throughout the entire workflow that this application is providing. And I think that would go a long ways to doing that. Now, that's super challenging, again, because these apps, I made it grossly simple when I was talking about my analogy with the valet. These apps tend to be extremely complex. They use all sorts of different open source in many cases, or a lot of the state of the application is stored in back-end databases, and these databases then can be changed or upset. And so it's very difficult. And so, obviously you want to have external protections that actually, are looking across multiple users and understand kind of the typical flows. And based on that, then they can help enforce permissions. And that's just one example, is that as soon as you see like anomalous behaviors of, say, users violating these typical flows, then you can flag that and say, oh, this is risk. We need to do something about that, and then make that visible to the security admin or the SOC, and say, hey, you might want to take a look here, and you may be valid, may not, but that's the type of visibility you need.
Yeah, and go ahead, John.
I want to pick your brain. I think you have an interesting viewpoint on something we've gone around a few times here on the show. Just looking at the API top 10, you mentioned. I heard the word bunches in there, which caught my ear for something I'm thinking about. There's bunches of these top 10s. Mm-hmm. So, and where I'm going is, you have a ton of experience both on the website plus the API side. How do you, still forming the question, unfortunately, but how do you think of, like, do we need a separate top 10, or how do you actually, what are those specific differences for you that require focusing on API security differently than on web?
No, that's a great question, because when you look at the OWAS top 10 for API security versus for web security or web applications, there's about half overlap. That is, about half of the ones on the web overlap, but they tend to be the not the stateful ones. They're not the big business logic protections. They're more kind of like we were talking earlier about cross-site scripting attacks, or those types of more, I don't want to say signature-based, but ones that tend to be easily blocked by rules, or a sequence of rules that they can detect a behavior and then basically shut it down. Whereas if you look at on the API Sec OWASP top 10, it's again these business logic flows, these things that you have to map out over time that are highly stateful and highly dependent upon identity, or users or interactions between systems and things like that. And so that tends to be much more difficult to detect. The other aspect that's quite different between a typical web application and like an API security application is that, or an API application, is that basically web application firewall has been around for a very long time. And typically when you're building a web application, it's a very well-known set of things. You have a well-known set of tools. So you got your web front end, you're using, Apache or something else well-known, and you're using your typical frameworks to build these things. They have a lot of that checking built in already for input validation, things like that, for example. And then you typically have that back-end application that fits in nicely, and it's a pretty well-known way to go build things, and you're building the flows through that very, explicitly. And so that's been around for a long time. And then it talks through a couple layers typically, and may eventually talk to a database or other aspects of your infrastructure. But with an API, you're going through a gateway. It's doing simple validation checks using tokens. It's letting you into the system, and then often it's talking directly to a database. So you don't have kind of the traditional set of things in between. You can go right to the heart of your infrastructure quite quickly. And so that's the danger there, is that it can let things through and get at more sensitive, infrastructure a lot easier. And so hence, it tends to be, I don't want to say it's easier to compromise, but boy, it's kind of a lightning rod for attackers these days. And especially attackers that can use, these more advanced, botnets. And other ways that they can slowly go and probe your applications and learn them over time, and then build up that kind of business logic, how it works and where the vulnerabilities are, and then attack based on those vulnerabilities.
Yeah, I like that. I like how you're framing that. I like John's question. I still don't know that even I would have a good answer for that. A lot of what you've been repeating, Karl, is that idea of that state diagram and these business logic exploits those transitions within the state, basically the unexpected transitions. And I think one of the other things you point out too, this gets really complex. And so that state diagram can be a very large directed graph, to be slightly, math geeky for a little bit.
Absolutely.
And trying to figure out, is that graph, how do you put that into one developer's brain to figure out these are all the different paths from this is the user to what they're ostensibly allowed to do, and are there controls in there? If I play a slight metaphor as well, we have React. That's my go-to example of a great way to minimize a framework, to minimize cross-site scripting. I don't know that we have similar work, similar types of things for state diagrams, state transitions, or even just frameworks around authorization. Because you mentioned API gateway, so we have a choke point, but I don't know that we're choking anything there at that point.
Yeah, no, I think you're spot on with it. You talk about these states. It's that app. That's why you build software. Is that you could build it all on hardware if it was fairly simplistic in terms of state management, and that's typically actually the delineation you make. In fact, I used to do that in the past. When I'll design an FPGA or an ASIC to kind of take on these things that are repetitive and simple, but the application itself has to kind of maintain state. And now these very complex multi-layered apps. Tend to leverage state in many different ways, and it's really hard, for standard developers to sit there and think or architects. Like, say you have an architect come in, and you do your best to kind of work out, okay, what are the valid flows or the transitions through this app? I go from this function to this function, but of course, a lot of times these functions have to respond to each other and do things and notify the previous, the previous function of its state for various reasons. And there's just a lot of that complexity, and over time, that grows organically. Typically, it's maybe when you first build it and you have a simple app, that's fine, but over years, these things grow organically, and you create these gaps and these voids, in your logic. And again, you can create these circumstances where, hey, I got certain states that this application get into. Now, in normal flows, you never get into it, but through manipulation, you can force it into these states, and then based on that, then you can exfiltrate or do whatever you're going to do to the application.
So I'm curious then, and maybe trying not to put you too much on the spot with this curveball, but to kind of riff on John's question, these top 10 lists, and there's a lot of overlap. Is there an area of the API security risks that you would point out as missing? Like, for example, would you add a number 0 to the top or a number 11 to the end?
Yeah, I think the thing that I would wrap the entire OWAS top 10 with is the fact that there's an attack surface due to the ability to probe and spend time using automations. That's typically the way you can get in at these. When I mean by automations, these kind of bad bot networks that are slowly. Typically the way they do it, by the way, is they tend to kind of do what I call a low and slow attack. They'll sit there and they'll come in from an IP address. They'll try to maybe come in from a different browser type, whether or doing different behaviors, and see if they can slowly probe the application to find these attacks. So there's this whole discovery process that they don't talk about as part of the OWAS top 10 that absolutely is a huge problem. So so if I was to say, hey, it's great that we're identifying these specific vulnerabilities, but there's an attack surface issue here that if you can reject that attack surface, then you massively reduce the ability of these these hackers to go and discover these flaws within the application. And that's what I'm referencing is hey, find a way to slow it down, to really make it difficult, using these automated techniques, and that itself should provide its own level of protections. I hope that makes sense.
I think so. I think, that aspect sounds is sort of like, if I try to boil it down to oversimplistic, is this is the human legitimate user interacting with the website as intended, as desired, versus the human or human-like automation that is doing that is anomalous in some way, to use that. So that's one of our favorite security words, right? But it's anomalous because of some marker in the browser. This is a scripted curl bot, or this is the Python headers.
Yeah.
Those are always. But I guess where I'm going with that though is that, and I think you were implying this as well. It is really hard to identify, is this a trusted client or not? and you were discussing more of what are they doing in that low and slow. So it's a little bit of what's the behavior here, and is this match the workflows that a lot of other people have been doing, or are they doing something out of order, or are they repeating a step in a workflow that nobody else tends to repeat?
Yeah, that's correct. There's a behavioral aspect, so you have to normalize, right, what a typical behavior looks like, and then based upon that, you can look at anomalies on that. I think you have to do more than that these days because AI models now are getting sophisticated. They're getting better at emulating kind of more of those valid human behaviors to figure things out. So I tend to say, if we're going to get into more detections, sometime looking further down the stack, if you will, of like, should this user be accessing this file type? Or this memory space, or things that are happening almost at that CPU level transaction, kind of in the runtime. Let's say, I think that's another aspect of being able to detect these types of things. Behavioral mechanisms are important, but they're becoming harder and harder with that AI arms race that's going on between attacker and defender, if you will.
Let's talk about some of that identification then too, because we've talked in the past about generative AI. Is that going to help the security side? Is it going to make things harder? This is a quick example. People talk about it can make phishing worse because it could be more realistic. But I would counter that with, if we're just still talking about phishing and pointing out good links or paying attention to grammatic errors, we're missing the point of what the real countermeasures should be. So is there something similar here where AI is actually making bots more insidious, either that low and slow, or on the other side, our developer side, is there a way to exercise those state diagrams with AI in a more effective way?
Absolutely. In fact, yeah, I mean, that's kind of the arms race I'm talking about, is that as developers, or as the attackers start leveraging it more to make, say, bots look more human, or to more quickly learn the vulnerabilities. That's the other aspect of this. They can figure it out quicker and build their own state. Developers can do the same thing. They can point these bots, and excuse me, not the bots, but they can leverage these large language models now to walk through their code and help point out the deficiencies perhaps in these complex states, right? And that can have more of a global view to walk through it and provide that information. And if done right, it should actually be more comprehensive, because it's easier for someone to actually attack their own code in that circumstance because everything's open, versus trying to come at it through multiple layers and attack. So theoretically, the developers should be able to get much better at building much better code and get rid of these like disallowed states, or ensuring that states within their code resolve appropriately, things like that. They don't get stuck. I think it'll help a lot with things, low-level things that attackers, exploit, like, being able to break at the OS layer, things like that. You can now see how your stacks are behaving under certain scenarios and things like that. You can run, so I think it just makes your test tools much more effective over time. So I definitely think there's an aspect to that, as well as, companies that provide tools to detect these types of exploits. That is, you can work in concert with these test tools. Good hygiene is that, one of the things we see a lot with our API security customers is that they will go and map out their entire APIs, the objects, the types of data that are transacting, and then they'll use that as a template during design time to ensure that like additional endpoints or other data is not being exposed. So that's a simplistic example. But now imagine you apply that to additional learning logic of how the application should behave, and then you can start knocking out these disallowed states and making other modifications, if you will, to the flows to your code. To your code.
It's funny. We often talk about how the attacker only has to be right once, right, to be able to compromise one of these sites. But thinking through what you're saying, if you have all these, incredible tools, AI, whatever have you, the developer or the organization has the code base that you're creating and protecting is relatively small compared to the surface which the attacker has to know and understand. So at least in theory, it sounds like they should be able to harden their environment, so to speak.
They should. I mean, it goes back to good hygiene, though, in the coding practices. You have to be very disciplined about what you allow in and when you test. And so that's the danger, is that let's say you got a developer who just happened to add like a new API, and they were doing some development work with that, and they inadvertently exposed that into the production network versus that's another example. In fact, there was a hack against a large company, industrial company that happened to provide a lot of agricultural products. And it was an ethical hacker that discovered it, but it was precisely that. They left open basically a developer API, and it exposed it in the production environment. So you can't really defend against those things easily, because that goes back to this hygiene. So yes, there's ways to ensure higher integrity with the code, but it also has to boil down to your practices as an organization, and then also just having defense mechanisms that can detect when these changes occur, and defend against those kind of from day zero.
I wonder too if there's that aspect of just how do you test for the changes that you've added. In your example, developer adds a new API. What are the side effects? Meaning that you could probably say this API is supposed to grant access or provide access to this bit of data, but it's really hard, even just in setting up tests, to recreate that state machine. In this particular state, they may not expect, oh, we didn't expect that, and this state actually pulls in this other data that was unrestricted. Have you seen that type of just testing that developers, are they still struggling with that? Are there ways that they've found increased maturity in tools or approaches to that?
Yeah, I mean, that's still something developers struggle with for sure in the tools, because there's a massive complexity in doing that. It's hard, like I said, this is where AI, I believe, is going to assist, because it's going to be able to discover and look at those states a bit differently than how we do it more statically today. It's just like how code validation tools, started out as doing static analysis back in the day. And then they started being able to look at more of the data structures and do more dynamic, evaluations of it, but still not really understanding the business logic, or, they could look at basic things. I think being able to map out that business logic, understanding the context of the user, and apply that more towards the overall, schemas that you're building out as part of these flows. I think that's what we're going to be able to see more and more of AI, but it's going to take time. And again, the problem is any large app can have, I don't want to say near infinite number of states, but can have just a massive explosion in these different states you're trying to walk through. So even then, it's going to be difficult to manage that. It becomes just that attack surface, and just doing and trying to manage and reduce kind of code complexity and other aspects. And I think it will help with that, but it's not going to solve it altogether.
One of the, perhaps reluctantly, I'm coming back to top 10 lists. Mm-hmm. And one of the common entries on all the top 10 lists seems to be, logging. Do you know what's going on? Is that, I'm going to try to reformulate John's earlier question, saying, is the logging different, or would you approach logging differently within web applications versus APIs in terms of what you're focusing on, or what's helpful both for a developer to debug, but probably more importantly for a security team to say, here's our bad bot. This looks hinky.
Yeah, the challenge with logging today is that you can have event fatigue. And that's, you can throw off so much data. It's just, how do you manage that data? And a common way to do that today is you log it off to a SIM, and then you have that, within that SIM, you have a specific, dashboard or something set up to kind of help you. Or you can do a forensic evaluation, but that takes time. And so one of the gaps that's there today is that you're not really getting insights and connecting the dots, because a lot of these attacks tend to be multi-layer. You got one coming in doing one thing, you got one doing another that's wiggling another part of the code. So it's hard to know kind of what to trigger. And then even if you're triggering on a lot of things, again, you just wind up in noise. And so I think you have to walk that balance of understanding the application and different layers of it, the authentication mechanisms, and setting up the appropriate, detections to trap those events. But then this is, again, where I think AI is going to play a bigger role, is to go in and then look at across this landscape of these, and then try to connect the dots on what's happening. I mean, that's the real way you solve these business logic attacks, is you use, kind of correlative mechanisms to look and see, oh, by the way, this looks like a coordinated attack. I just couldn't see it because it was in, like I said, low and slow and in the noise. And so the faster you're able to do that, the faster you're able to kind of stop that attack. It's the same thing with, trolling through all this data. It's being able to kind of pick out the events that are meaningful and that are correlated, and then be able to present that in a way that tells the like the SOC or the security admins or whoever, or it could be the developers. Okay, so this is what we see here. Now, what are the appropriate next steps? Give them more insights and actually actionable intelligence on what they should think about or do next, or where they should be looking. Hope that makes sense.
I think it does, and it's that idea that what's coming through are not the obvious payloads of the SQL injection cross-site scripting, to go back to the earlier part, and that a lot of people are going through these workflows. And as you said too, it doesn't matter if they're infinite or not. Once they get above a large number, they're infinite enough for sure to try and reason through. So is this someone who just ended their shopping cart process, abandoned the shopping cart, but then came back later on to put something in, versus someone who's trying to reapply the same coupon code 10 times in a row to get some extra discounts, the type of thing. All of that is legitimate looking. That could also be slow behavior. You don't have to do that super fast to make it successful.
Absolutely. Yeah. I mean, that's a great example. It's like, how do you, like, let's say you wanted to go buy tickets for a Taylor Swift concert. It's the same type of thing. Can you come in and either exploit the application or exploit kind of the normal channels so that you can grab a bunch of these tickets before anyone else? And it could look like a valid user, but really from the point of view of what they're seeing is it looks like 10,000 users just coming in normally to go buy it when it's really just one or a few. And so that's kind of that same notion of how do you detect that? How do you say, nope, this is not something we should be seeing? And again, that comes from a lot of different mechanisms, everything from behavioral to looking across, simultaneous connections to understanding, typical user behavior. There's a bunch of ways to look at that and see what you can do there. But again, it goes back to looking at kind of the totality of how things are working across that application environment.
Yeah, and I think too, just to reinforce the point, in addition to the totality of how things are working, look at what the consequences of the attack are. We're talking about the Taylor Swift tickets because those are quite valuable. There's a lot of value that can be gotten out of here. In addition to picking up that Porsche after dining from the valet. But it's not these. This is why I think these business logic can be more insidious, because there's a lot of value there, and there's a whole reason people build up botnets, because they're investing money and their own time in doing this research.
Yeah, no, absolutely. Again, the business logic is where the pay dirt is now. Like I said, these other less stateful attacks are much easier to block and defend, and this is becoming kind of that new horizon of like, hey, I know that there's probably a flaw in there somewhere. The old joke is, how do I know there's a how do I know there's a bug in my code? Well, a line of code has been written somewhere. You know what I mean? It's just, there's always going to be bugs or problems, and you can do the best you can to reduce that, but they're still going to be there. 20-year-old code bases are still getting cleaned up. So it's very simple that, hey, no matter, I can take that developer-centric approach, which is great. You should have that best hygiene, but there's always going to be a way in, and it's just a matter of time till someone finds it. So you want to make sure you're doing your best, either have that multi-layered approach to stopping these attacks.
Mike, he's saying,
I love the point. Yeah. I was going to say along those lines, mentioning 20-year-old code is still being reviewed. That's 20-year-old code that's still running plenty of web apps out there, for sure.
Absolutely. And it's just, a lot of times you don't even know you have problems in that code until somebody finds it for you, right? In terms of a new attack type. I mean, what's a good example? The move it vulnerability. That's been around for a long time. And so somebody finally found that. And boom, it was a massive problem. Same with log4shell. There's just a lot of these examples of things that have lived for a long time in the code base, and it just took somebody trying to figure it out, and boom, there you have it.
Boom, there you have it is a couple more words than we usually ask our guests, Karl. And what I'm setting up here is to describe AppSec in 3 words. So I'm not sure if you can narrow that one down if you've got a different 3 words in mind for that topic.
No, I mean, the way I tend to think of application security, in 3 words, I think fits well. Number one is visibility, because when an organization buys or thinks about security, they think of it as kind of an insurance policy. And they're only willing to spend so much based on a perceived level of risk. And so in order for them to understand what that risk is, you have to present it to them. They need to see it, because often, I'll use the example of a bot attack. You don't know you have a bot problem often until suddenly you've been exploited. You've been hacked or something like that. And so that's a big problem. It could be going on for a long time, maybe months or years, but eventually they get through. And so if you knew that you had that, you might have taken preventative measures up front. And then with visibility becomes, what do you do once you are, or how do you know exactly what's happened? Providing essentially the remediative steps to deal with these vulnerabilities in your system, or how do I deal with the data that perhaps was exfiltrated? Having that visibility there, and so that's a critical aspect of it. The other aspect, and this is more important today than ever, is availability of the application, because you build it to run your business typically, right? These business critical apps, and it needs to be up. If it's not up in this world, then you're losing money. And so availability is absolutely an aspect of that, of security, is that if the app isn't running, then you're dead in the water. And often today now, what we see a lot in organizations is that it's no longer the security team that's calling the shots on what you're going to use for security. It's being partnered with the business team, and the business team has a veto. That is, hey, if this is getting in the way of business or my workflows, and it's not helping me, and it's affecting the business transacting, then they can shut it down. And so, and they're as much of a decision maker as others. So availability is a key aspect of that. And of course, the final one is like protection, right? You've got to protect the apps. You got to block it against these attacks. But those are kind of the 3 things that I tend to think about when I think about application attacks, or just application security in general.
No, and I think I love how different and unique all the responses have been, because I don't know that we've got maybe one of those 3 words has is a repeat, but otherwise nice, unique, and different, which has also been what's been enjoyable about this conversation. So I thank you again, Karl.
No, I appreciate it, Mike. No, I really enjoyed the conversation with you all today.
Thanks again to Karl. Thank you to John. Thanks to everyone else. We're going to take a quick break and return with news of the week.